All right, parallel lines and proportional parts, lesson 5-2 today. This one is pretty lengthy, so I'm going to try to go through it really fast with you. If you remember from class, it was everyone's favorite once we get to example 3. So let's just go ahead and get started. That way we can get this one done and the video won't be too long. So we start talking about mid-segments, but we don't actually do anything with mid-segments till example 3. But if you recall, a mid-segment's a segment with endpoints that are midpoints of two sides of the triangle. And I'm not even going to draw the triangle because we will get to that part. So our first theorem, it says the triangle proportionality theorem. It says if a line is parallel to one side of a triangle, so BD here is parallel to AE there, and it intersects the other two sides in two distinct points, so that's point B and point D, then it separates these sides into segments of proportional lengths. So the segments they're talking about is C to B, C to D, and then B to A, and D to E. So moving right along with that in our first example, it says in triangle RST, RT is parallel to VU, SV is 3, VR is 8, and UT is 12. We have to find SU. So since those two lines are parallel, we know that triangle proportionality theorem that 3 over 8 must be proportional to x over 12. And remember, there's 4 different ways again that you can set this up. So when we cross multiply, we get 8x equals 36, and x is going to equal 4.5. So to check this, you could substitute it back in, and if we do that, 3 divided by 8 is 0.375, and if I put 4.5 divided by 12, we do get 0.375. So it checks out, and that one's right. So take a moment, do the your turn, and then we'll go to example 2. All right, so hopefully you've unpaused the video now. It's the same scenario, so we're just going to go ahead and get into it. So I'm going to do 4 over 10.5, so I did left side over left side, equals the same right side, so 6 over x. So if we cross multiply, we get 63 is equal to 4x, and x is equal to 15.75. So that's D, and that one is done. All right, the next theorem is just the converse of the triangle proportionality theorem. So before it said if that segment was parallel, then we know it's split it into proportional segments. Now it's going to say if those segments are proportional, then we know that those two segments, BD in this case and AE, are parallel. So our second example, it says in triangle DEF, so that is the large triangle, D to H is 18, H to E is 36, and DG is half of GH. Okay, we have to determine if they're parallel. So if these two are parallel, then that means these proportions will work out to be true statements. So there's 2 different ways to do this. If we know that this segment is half of that one, then DH should be half of HE. So DH should be or is half of HE. So then if we substitute everything in, 18 equals half of 36. Half of 36 is 18, so 18 equals 18. That right there is our proof for showing it. There's another way to do it. Some people prefer more to set up a proportion. So if we go back and follow this, we don't know what GF is, so I'm going to call that X, and DH is half of that, so that's 1/2 X. Then we can set up a proportion. So here's the second way to do this. We could do 0.5 X over X, so I did left side over bottom left side, equals top right over bottom right. Again, we're going to cross multiply, so 18x equals 0.5 times 36x. 18x equals half of 36 is 18x. So again, it works out. So that one is also true. All right, so try the your turn, pause the video, come back, we'll finish that one up. All right, so they gave us the figure. It says triangle WXZ. X to Y is 15. Y to Z is 25. W to A is 18. And A to Z is 32. So let's go ahead and set up our proportion. So I'm going to do 25 over 15 is equal to 32 over 18. And again, question mark, because we're not 100% sure that it's equal since we don't have any variables to find. So if we go ahead and cross multiply, you could also just simplify your fractions, but I cross multiply. We're going to do 480 is equal to 450. That is not true, so they are not proportional. But if you did go back and simplify your fractions just to show you, you get 5/3 is equal to 16/9. And again, they are not equal, so we know that WX is not parallel to AY. All right, and now the problem you've all been waiting for. Example 3. That might take us all day to get through. So it says the midsegment of a triangle is parallel to one side of the triangle and it's half the length of that side. So that's what we're actually going to be using for this next problem. So triangle ABC has vertices of -2, 2, 2, 4, 4, -4, and it is telling us the DE is the midsegment. So therefore we know that D is the midpoint of A to B, E is the midpoint of A to C, and DE should be parallel to BC. We have to find the coordinates of D and E. So to find the coordinates, I just said that D must be the midpoint, so guess what formula we're using? Midpoint formula. So let me write midpoint formula here so we don't forget. All right, so midpoint formula. So I'm going to do D first. So coordinate D we'll do over here. So remember, midpoint formula says add your x values, divide by 2, add your y values, divide by 2. So I'm going to do -2 plus 2 divided by 2, comma 2 plus 4 divided by 2. So I get 0 over 2, comma 6 over 2. Simplify that, we get 0, comma 3. So the coordinates of D are 0, 3. It's going to be helpful to us later. Now to get the coordinates of E, we do the same thing. So coordinates of E, I have to use points A and C now. So I'm going to do -2 plus 4 divided by 2, comma 2 minus 4 divided by 2. So I get 2 over 2, comma -2 over 2. So we get 1, comma -1. And that are the coordinates of E. So the first one wasn't too bad. So since we know the D and E were midpoints, we use the midpoint formula. For part B, oh look, there's all my work from when we went through it in school. So for B, it says triangle ABC has vertices, same vertices. DE is the midsegment, same thing. But now they're asking us to verify that they are parallel. So if you remember, to show that something is parallel, you need to find their slopes. So you can see on the left-hand side here, if I'm finding the slope of D to E, so we had our two coordinates, D was 0, 3, and E was 1, -1. Went through, found the slope. The slope for that line is -4. For B to C, oh, and again, my slope formula is up here. It's also on your formula sheet. The slope for B to C, we had to take -4 minus 4 all over 4 minus 2. We simplified that. We got -4 as well. So showing that those two slopes are the same is verifying that they are parallel. I wonder how much other work is here. All right, so finally C, they gave us an equation and told us to use it. So it says verify that DE is half of BC. So we had a bunch of different steps here. So in order to verify that it's half, that's talking about length. And length on the coordinate plane means distance formula. So as you see, we had to use the distance formula to find the length of D to E. And then we had to use it to find the length of B to C. So distance formula I have up here. It's also on your formula sheet if you forget it. So x sub 2 minus x sub 1 squared plus the quantity y sub 2 minus y sub 1 squared, and then the square root of all of that. So we have all the coordinates, so substitute everything in. We found that D to E was the square root of 17, and B to C is the square root of 68. So now that was our first two steps. And now the third step is to verify that DE is 1/2 of BC. So we wrote that down. We wrote DE is 1/2 of BC, and then just substituted in those values that we found in steps 1 and 2. And when we work through it, simplify those values, we got 4.12 is equal to 4.12. So it worked out perfectly. All right, I'm just going to go ahead and show you the answers for these next couple problems because I'm running out of time here. So for A, and do it, make sure you can get all this work, is D. Part B is yes, they are parallel. You actually get that both slopes are -5. And C, the answer is yes. When you go through and do this work, that's what the left side and right side should be equal to. All right, one last thing, and example 4 and example 5 are just like what we did for example 2, except they're not just triangles, they are lines that create triangles. So it says if 3 or more parallel lines intersect two transversals, then they cut off the transversals proportionally. So that was the first one. And the second one said if 3 or more parallel lines cut off congruent segments on one transversal, then they cut off congruent segments on every transversal. Okay? So meaning if AB is congruent to BC, meaning their lengths are equal, then I know that DE and EF are also equal because of those vertical lines. I'm sorry, those parallel lines. So here's the first one. It says in the figure, Larch, Maple, and Nuthatch streets are all parallel. The figure shows the distances in city blocks that the streets are apart. We had to find X. So again, we set up proportions. We did, I don't even know if it'll let me erase this. Oh, it does. All right, so I'm gonna go ahead and erase this and we can do it together. All right, so we can set up a proportion. We're going to do 13 over 26 equals 16 over x. So once we cross multiply, we get 13x is equal to 416. Divide both sides by 13, we get x is 32. And that should make sense because 13 is half of 36, and 32 so 16 is half of 32. All right, take a few moments, do the your turn, come back to the video, and check your answer. All right, so you can already see all of the work there for that problem. So that's wonderful. Last one, example 5. I'm sure there's work here too. Looks like we were unhappy about something. All right, so we went through, it says find x and y. So what we did is we went through and we set up proportions. We did 2x plus 2 over 3x minus 4. And then we did 8/3 y plus 7 all over 5y. And then if you remember, we have this the sad face there because we can't solve that. Because we have x's and y's. So then we had to go back and say, okay, what information did they give us in the picture? And if you see here through all my writing, they told us that. So that tells us that those two segments are equal. So we went through, set them equal to each other. Did it come on? Set them equal to each other and solved it. So we subtracted, sorry, this right here is where we are now. So we subtracted 2x from 3x and added 4 to both sides, and we got x is equal to 6. So that was wonderful. We did that, and then we went through, we actually set up a proportion first, went through all of this mess and found out, hey, when we went ahead and did that, we ended up just getting that those two segments were equal to each other. So then if you remember, we went back to the lesson. I went back. And we said, hey, if the line cuts them into congruent segments, then they cut off other congruent segments. So then we went back and we said, oh, we could have just set these two equal to each other right away. But in any event, we went through, solved it, and we got y is equal to 3. All right, so that's the end of lesson 5.4. We have next up is parts